Okay, so good afternoon. My name is Catarina Fonseca, and for my thesis, as Ian said, I worked on the description of the diving and foraging behavior of fin whales in the Azores using time depth recorders. So as we all know, foraging is an essential behavior that allows the animals to meet their energetic requirements, but is also associated with high energetic costs. And this forces the animals to make optimal decisions about where, when, and how to forage. So fin whales are filter feeders and feed mostly on small and patchily distributed prey, especially krill and small pelagic schooling fish. They use a complex feeding mechanism called lunging that allows them to efficiently explore these dense patches of prey, and that can be divided into three phases: a sudden acceleration in the direction of a prey patch, a sudden deceleration when they open their mouths to engulf large quantities of water and prey, and the closing of the mouth when they filtrate the water, retaining only the prey items. This mechanism is believed to be extremely energetically demanding, limiting their dive duration, depth reached, and the number of lunges per dive, as well as extending the time needed to recover at surface. And therefore, fin whales have to adjust their feeding strategies to the depth and density of their prey, and may cease foraging if prey is insufficient to reward. So regarding their migration, these whales are thought to migrate every year from high latitude productive areas where they feed during summer to low latitude breeding grounds in winter. And in the Azores, they are commonly sighted during spring and summer right after the spring bloom. And although this area is usually characterized as being low productive, previous studies stated that they can remain foraging in the area for up to 2 months. And therefore it has been hypothesized that the oceanographic and topographic features present in the area may lead to higher concentrations of biomass, creating these temporary foraging hotspots. So this is the first study to describe the two-dimensional diving and foraging behavior of fin whales in the Azores, and the aim is to provide a better understanding of the foraging strategies employed by these migratory baleen whales in this type of habitat. So the archipelago of the Azores is located in the northern hemisphere of the Atlantic Ocean, and this study was carried out off the coast of Fayal and Pico Islands, which are characterized by the absence of continental slope and the presence of deep waters near the coast. Although this area is usually characterized by low levels of chlorophyll A, the region experiences strong spatial, seasonal, and interannual variability, which leads to peaks in productivity during spring and winter. So the data utilized in this study was collected using time depth recorders, which recorded depth, temperature, and light data at a frequency of 1 Hz, and it was collected between April and September from 2007 to 2017. These tags were deployed using a compressed air gun and Domeyer darts that were implanted in the adipose tissue of whales, significantly increasing the duration of attachment. All tagged whales were then followed during daylight hours until the tag detached or the animal was lost. And the duration of these deployments ranged approximately from 2 to 41 hours, and individuals with recordings inferior to 5 hours were excluded, giving a total of 18 individuals analyzed in this study. So regarding the data processing, since TDRs often show drifts, which shifts the surface baseline from 0 meters to another depth value, as we can see in the first graph, the first step was to calibrate the data. So all these errors were corrected, and in all deployments, the surface baseline was shifted to the 0 meters, as we can see in the second graph. After this step, a dive was defined as any submergence deeper than 15 meters to exclude surface respiration activity and traveling behavior, and then each dive was divided into 3 phases, so descent, bottom, and ascent. Then 7 metrics were calculated for each dive: maximum depth, dive and post-dive duration, descent and ascent rate, bottom duration, and the proportion of bottom time on the overall dive duration. Finally, to investigate the dial patterns of these whales, all dives were divided into 2 different light regimes, day and night, using local sunrise and sunset times. So for the analysis of foraging behavior, several algorithms were developed in R to detect potential lunge feeding events. This algorithm applied several criteria that were based on the vertical excursions performed by these whales at depth, their vertical speed, and on lunge and interlunge duration. And these criteria were based on information that was present on previous literature on the kinematics of fin whales when lunging. So the algorithm would then identify local minima and maxima, as we can see in this graph, as potential launch start and end points. Several combinations of these criteria were tested, and the results were visually inspected to assess their performance at detecting potential launch feeding events. For the statistical analysis, linear mixed effect models were used to compare all dive metrics, so maximum depth, dive duration, etc., between foraging and non-foraging dives, with foraging dives representing dives that contained at least one launch detected. In all models, the interaction between dive type and dial period was included, and whale ID was used as a random effect. Additionally, weights were used to account for variance in individual measurements, and a correlation structure was applied to account for temporal autocorrelation. So regarding the results, a total of 2,606 dives were analyzed, from which 1,307 were classified as foraging dives. And within these dives, a total of 2,343 lunges were detected. So the deepest dive reached 339 meters, and the longest dive lasted for about 17.3 minutes. And also the majority of the dives, around 80%, were carried out in the first 100 meters of the water column. Fin whales lunged on average 1.8 times per dive, reaching a maximum of 7 lunges in a single dive. And as we can see by these graphs that represent the total number of foraging dives per depth bin during day and night time, average foraging depth was higher during the day compared to overnight. Also, fin whales allocated on average 29% of their tag time to foraging activity, but this varied between individuals and between both dial regimes. So regarding the modeling results, all dive metrics were significantly different between foraging and non-foraging dives, for the exception of post-dive duration. So regarding maximum depth and duration, foraging dives were deeper and longer than non-foraging dives in both light regimes, and both dive types were shallower and shorter during the night period. Foraging dives also presented steeper trajectories, so both descent and ascent rate were higher for foraging dives, and there was a dial difference for the metric descent rate, since these would increase for non-foraging dives overnight, and there was no dial differences for the metric ascent rate. Bottom duration was also longer in foraging dives in both light regimes and decreased for both dive types overnight, and bottom proportion was higher in foraging dives in both light regimes and increased significantly for foraging dives during the night and decreased for non-foraging dives in the same dial period. So post-dive duration, as said before, didn't differ between foraging and non-foraging dive, but it decreased for both dive types overnight. To start my discussion, I would like first to state that identifying lunge feeding events in 2D dive profiles is quite challenging because it is hard to detect subtle changes in movement and speed associated with their lunging behavior. But with the new insights that recent studies provided with higher resolution data that provided a better description of their lunging behavior, there is an opportunity to increase the detection of such feeding events in two-dimensional data. So regarding the algorithm utilized in this study, unfortunately, until now, it could not be validated, so I cannot report the error associated with this approach. But by including several criteria to detect the lunge, the number of false feeding events is believed to be minimal, although this could also mean that the number of lunges and estimates of foraging activity may be underestimated due to this conservative approach. So regarding their dive behavior, all dive durations were well below the theoretical aerobic diving limit estimated for these whales, which is around 28 minutes. And this is in agreement with previous literature that relate this limit to the costs of their lunge feeding mechanism. All the differences between foraging and non-foraging dives were also in agreement with the description of these dives in previous literature, except for post-dive duration. And this could be related to the foraging strategy that these whales employ in the Azores. since, for example, 47% of the dives, of the foraging dives performed by these whales included only one lunge, and as said before, they lunched on average 1.8 times per dive. And this differs significantly from the results reported in more productive areas, where they said that fin whales would perform between 4 to 6 lunges on average per dive. So one possible explanation for these differences is that the algorithm failed to detect several lunge feeding events, for example, horizontal lunging, which was not accounted for, but other factors may have contributed for these differences. For example, since fin whales foraged mostly in the first 100 meters of the water column, although prey is supposed to be concentrated at higher depths, this may suggest that fin whales in the Azores minimize their foraging effort by reducing the number of lunges per dive and foraging at shallower depths. Also, these single lunge dives could simply represent exploratory dives when they assess if prey quality is sufficient to reward foraging or not. Regarding the dial patterns of these whales, fin whales in the Azores foraged both during day and night, and they would perform their deepest foraging dives during the daytime, and then they would remain foraging at shallower depths overnight. And this pattern has already been described for several baleen whale species and is believed to be associated with the dial vertical migration of prey, since most baleen whale prey usually remain at greater depths during the daytime, where they form dense aggregations, and then ascend to the surface layers during the night, when they disperse in search for food. So since fin whales in the Azores also forage during the nighttime, when prey is supposed to be more dispersed, this could have implied increased energetic costs and could also partially explain the low number of lunges observed in this study. Also, since even during the day, fin whales forage mostly in the first 100 meters of the water column, this may suggest that prey in the Azores is insufficient or is too deep to compensate their increasing diving costs. Nevertheless, there was some variance in the behavior of these whales and in their dial patterns, and therefore the distribution of prey alone cannot explain their behavior. Other factors may have contributed for these differences in behavior, such as individual differences in body condition, since when these whales reached the Azores, several months have passed since they left their feeding grounds, and therefore whales with lower fat reserves may need to increase their foraging effort, while whales in better body condition may forego foraging in the Azores. Sex of the whales and seasonal and interannual variability could have also played a role, but due to the small sample size, this could not be accounted for. So to conclude, I would first like to state that the results in this study substantiate the previous evidence that fin whales use the Azores as a migratory foraging ground, and that provide also a first step for a better understanding of the foraging strategies that fin whales use in this area, but also in this type of habitat, so oligotrophic waters. The results suggested that they employed a best cost-benefit feeding strategy, which was to minimize their foraging effort by reducing the number of lunges per dive and foraging at shallower depths, especially during the nighttime. And as a next step, to better understand their foraging behavior in this area, it would be important to combine these data, so the dive profiles and the GPS locations of these whales, with prey abundance and distribution data, as well as with environmental data, to assess the minimum prey threshold for these whales to forage in the area, and also to be able to identify the major oceanographic and topographic features that may affect their behavior. Lastly, to conclude, information on the 3D movement of these whales should be obtained for a better description and identification of their lunging behavior, and this could be done, for example, using D-tags, and this would also allow to validate and even maybe improve the algorithm utilized in this study to detect lunge feeding events. So thank you for your attention, and that's it.